Right, so now we're going to talk about a couple other identities that are established in this course. The proof of each of these identities is in the textbook. You're not responsible for the proofs, but if you want to understand where the formulas came from and that they didn't come from midair, that they came from exactly what we've been working on, I encourage you to look at them in the book, and I'm happy to further explain in more detail on Zoom in the office hours at some point. So in this section, there's actually a fair number of different identities given. So as you look through section 7.2 in the book, you're going to see that there are other identities. These are the only ones that we're going to be doing. We're not going to be doing product to sum identities, nor sum to product identities. Not that they're not amusing and not that they're not interesting. It's just we only have so much time, and we're just going to focus on these. Okay, and if these are all that I'm going to be talking about and assigning homework on, that's all that obviously you're responsible for. All right. So my hint to you in this whole section is think of the common angles that we know. We know sine, cosine, tangent of 45 degrees, 30 degrees, 60 degrees, and then of course everything on our unit circle. So for example, if I wanted you to find the exact value of cosine of 15 degrees. Well, it would be reasonable to be like, how? I can get a decimal representation, but I don't know the exact value. And once we're asked for the exact value, a decimal approximation is not sufficient. So I want to look at what common angles we know. Well, I claim that I can say, well, 15 degrees is 45 degrees minus 30 degrees, and we certainly know those for our cosine and sine. Or I could say it's 60 degrees minus 45 degrees. Either way, you're going to get 15 degrees. Okay, I'm just going to use the bottom one for absolutely no good reason. You're going to get the exact same thing if you use this top one. Okay. I claim that I can write the cosine of 15 degrees is the same as the cosine of 60 degrees minus 45 degrees. I've now written this as the difference of two angles, and I can use my formula up here. I can say, well, that's equal to the cosine of 60 degrees times the cosine of 45 degrees plus the sine of 60 degrees times the sine of 45 degrees. And this is where it really helps to know these things off the top of your head. But again, you can always look them up as needed. This is 1/2. This is root 2 over 2. Sine of 60 is root 3 over 2. Sine of 45 is root 2 over 2. So I claim we get the square root of 2 plus the square root of 6 over 4. Pretty cool, huh? So let's see. What if I want us to find the exact value how about the sine of let's see. Let's do 255 degrees. Okay. Well, I know that 255 is equal to, let's see how, okay, one way we can do this is the sum of two angles is I can say that 255 is certainly the same as the sine of 225 plus 30. And you might say, well, what? Sine of 225 degrees? But think about this, 225 degrees is a common angle that we know, because notice that's 180 plus 45. Okay, bear with me here. So I think you'll grant me this much so far, and I'll show you how we're going to use this guy in a second. Well, this tells us that that's equal to the sine of 225 degrees times the cosine of 30 degrees plus the cosine of 225 degrees times the sine of 30 degrees. Okay, 225 degrees, I told you, is 180 plus 45. Okay, well, remember, the 45 degrees is my reference angle, 180 plus this 45. I know what the sine and cosine of 45 degrees are. They're both root 2 over 2. But I also would then claim that since we're in the third quadrant, they're both negative. So we get negative root 2 over 2. So what do I have? I have negative root 2 over 2. The cosine of 30 degrees is root 3 over 2. Plus cosine of 225 degrees is another negative root 2 over 2 times 1/2. So what do we get here? We get negative root 6 minus root 2 over 4. Again, perhaps not the most satisfying, but this certainly works, and it is our exact answer. So having these sum and difference formulas help us find exact values of more angles than we were originally able to deal with. Okay, so using these, and again, you don't need to memorize these, just have them in front of you. Okay, what if I want us to rewrite the sine of x minus pi over 4 in as simple of a way as possible? Well, what I would do is say, well, I'm going to use my sine difference formula, and I'll rewrite this as the sine of x cosine pi over 4 minus cosine x sine pi over 4. And then substitute in the values that I do know. I know that this is root 2 over 2, and I know that this is root 2 over 2. So essentially, I'm going to have root 2 over 2 sine x minus root 2 over 2 cosine x. Perhaps not very satisfying, but we did make some headway. All right, now what we're going to do is look at them kind of bebopped. Okay, check this out. What if I wanted you to solve sine x sine 2x plus cosine x cosine 2x equals 1/2? Now, on first sight, this looks like a nightmare, but go back to your formulas here. We've got sine, sine plus cosine, cosine. Where do we have sine, sine plus cosine, cosine? We have that right here. Okay, notice we have the commutative property. Okay, essentially, what we're saying is we've got the cosine difference formula. Okay, notice prior we were starting here and going this way. Now we're starting here and bebopping back. I claim this is the same as the cosine of x minus 2x, and I want to solve that equal to 1/2. Well, that's the cosine of negative x equals 1/2. But I know that my cosine is an even function, so the cosine of negative x is the same as the cosine of positive x, and that's equal to 1/2. Where is my cosine positive? It's positive in my first quadrant to my fourth quadrant. This is one of our common angles. I know in my first quadrant, it's pi over 3 or 60 degrees. So pi over 3 will be my reference angle in my fourth quadrant. So 2 pi or 6 pi over 3 minus that reference angle pi over 3 will give me 5 pi over 3. All right, let's just go through one more. What if I give us find an approximation for sine 21 cosine 22 plus cosine 21 sine of 22, and these are in degrees. Well, we could literally just push those into our calculator, but just so that we get a bit more agile with these formulas, we'll ask ourselves, which one of these sum difference formulas gives us sine, cosine plus cosine sine? That's my sine sum formula. So I claim this is actually the same as sine of 21 degrees plus 22 degrees. In other words, all we're really asked to find is what is the sine of 43 degrees. Okay, now again, you want to make sure that when you're doing these computations that you're in the correct mode. So I just made sure that I was in my degree mode in my calculator, and the sine of 43 degrees is about 0.682. All right, well, have a ball playing with these.